Hello friends, good morning. My name is Arpit and I am here with today's analysis. Today is 24th of August and we are going to cover a very important achievement by our country. Yes, yesterday, that is 23rd of August, we were the first country to do a soft landing on the lunar south, that is south pole of the moon. And hence, in today's class, we're going to discuss about Chandrayaan 3. Now, many people all across our country are talking about this particular mission, the success of this mission. We will also be doing the same, but we will be covering this particular topic from exam point of view. How UPSC can frame questions from this particular topic in prelims as well as mains. So let's begin with today's class. Now about this Chandrayaan 3 mission year 2023, when we started about it, it was somewhere around 2019 only. This was the year when Chandrayaan 2 failed. At that time only we started Chandrayaan 3. Then status, we all know. No need to mention about this explicitly that it is successful. Mission duration, when I talk about it, actually it is 14 Earth days or 1 lunar day. We have a rover named as Pragyan, kind of a robot that will be, going on traveling on the surface of the moon, doing various experiments. Doing various experiments for 14 Earth days. 14 Earth days is equal to 1 lunar day. Launch vehicle on which this Chandrayaan 3 was launched was Launch Vehicle Mark 3, LVM3. And this particular operation was called as LVM3M4. That is, the fourth mission on LVM3 was Chandrayaan 3. So don't get confused if you read this term LVM3M4. LVM3M4 is Chandrayaan 3. It was Launch Vehicle Mark 3's fourth mission. Then mission location on the moon, it is lunar south. India becomes the first country to do soft landing on the lunar south. Has anybody done that before or attempted that before? Yes, just before us, Russia attempted. Lunar 25, we covered that in that video, but that was a failed attempt by Russia. So this is a remarkable achievement that we have become the first country to do soft landing on moon. Now when I say soft landing is a type of landing in which a spacecraft lands without getting destroyed. On the other hand, there is another type of landing, that is hard landing. Hard landing is when it lands and it gets destroyed. Now, India in Chandrayaan 1 did hard landing, and that also hard landing was done on the lunar south pole. The prior missions, Chandrayaan 2, 2019, it was partially successful. We'll discuss why I am calling it partially successful in the coming slides. Chandrayaan 1 launched in 2008. It was successful. It was hard landing mission which hard landed on the south pole of moon. Chandrayaan 2 was a soft landing mission. We failed to do soft landing in Chandrayaan 2 in 2019. And the very same year, we started preparations for Chandrayaan 3. So, this is the basic detail about it. Now, the timeline with respect to Chandrayaan 3. July 14 was the launch date where, it was launched from the Sriharikota Space Center. Launch Vehicle Mark 3 lifted it. Then, July 14 to July 25, this Chandrayaan 3 was orbiting around the sun. From August 1 till August 16, it was inserted into the lunar orbit and orbiting around the moon. It took a slingshot and went here. This particular phase was called as Trans-Lunar Injection, TLI. Okay. Trans-Lunar Injection. Now, August 17, lander which has landed or which has done the soft landing on moon, lander is named as Vikram. It is on the name of Vikram Sarabhai, the founding father of the Indian space program. The lander separates from the propulsion module. The propulsion module carried it to the orbit of the moon. It was the propulsion module which was making it rotate around the moon. So, it separates from the propulsion module and begins its journey downwards towards the surface of the moon. And finally, yesterday, the D-Day, August 23, Chandrayaan 3 does soft landing on the surface of the moon. So, this was basically the timeline. We took more than a month, July 14 till August 23, almost 40 days to accomplish this mission. Now, whereas, just in this time frame only, there was this Lunar 25, which was just a 11-12 day mission, which unfortunately could not, I would say, be successful. So, there were reasons that why we took so much time, because of earlier we were, revolving around the earth, then revolving around the moon. Lunar 25 did not do that. Now about Chandrayaan 3, the details of Chandrayaan 3. Chandrayaan 3 had three, I would say, components or three major modules. The first was the propulsion module. Propulsion module basically was carrying the lander module and the rover. This image which you see, as it has been taken from ISRO's website, is an integrated module. It has the propulsion module, lander module and the rover, all are here. The lander module separate is this, the propulsion module separate is this. When they are clubbed together, they look like this. Inside this lander is the rover. See, in this image you can see the lander. This lander did soft landing yesterday on its feet. The rover came out. The rover's name is Pragyan. Now the three, I would say, modules, major modules. One is the propulsion module, which was carrying the lander module. Lander module had in it the rover module. So technically speaking, propulsion module was carrying the lander module as well as the rover module. Propulsion module is where? This is the moon, let's suppose. Propulsion module is still rotating in the orbit of the moon. It is believed that if, it is a possibility that this propulsion module keeps on rotating for years in the orbit of the moon. What function will it do? As such, no function it will do. So, this is the basic, I would say, components of Chandrayaan 3. Now, Chandrayaan 3 is a planned third lunar exploration mission by ISRO to demonstrate end-to-end capability in first, soft landing. I told you what soft landing is. It is a kind of a landing in which the module which is getting landed does not destroy. It softly lands. Then, after landing, it fulfills the intended purpose. Then roving, it is kind of a robot which is inside the lander. So we have to demonstrate end-to-end capabilities first in soft landing, which we did yesterday. For the very first time, we demonstrated soft landing. Roving, the Pragyan rover has come out of this, I would say, lander Vikram. The ISRO has shared images on its social media. Now this rover will do all its tasks. What are its tasks? We will discuss abhi shortly. Now, unlike Chandrayaan 2, it will not have an orbiter, and its propulsion module will behave like a communication relay satellite. Now we'll discuss what is this, what does this mean by a comparison between Chandrayaan 1, 2 and 3. Now when I talk about the comparative analysis, from here also a question can be asked. Chandrayaan 1, 2, 3. All launched by ISRO. No need to say. 2008, 2019, 2023. Hard landing. Soft landing was the mission. Plus roving. The same kind of mission was here. Soft landing plus roving. The components in Chandrayaan 1, orbiter, which took the hard lander, and there was the moon impact probe. This moon impact probe, MIP, did the hard landing. The orbiter took that moon impact probe in the orbit of the moon, dropped it. This moon impact probe went down on the south pole of the moon, did hard landing, got destroyed, the mission over. Now what was the purpose? Actually, when this moon impact probe was going down, that was collecting data from the atmosphere of the moon. That was the basic objective of this. And hard landing had to be done. As soon as hard landing was done, MIP was destroyed. Now in Chandrayaan 2, we went a step ahead. We said that this time we will have an orbiter which will carry the lander. The lander will be doing soft landing. The lander will have a rover. This was our next step in Chandrayaan 2. Now Chandrayaan 2 orbiter was successful, but we were not successful in doing soft landing. There was a software glitch due to which we lost communication with the lander just before it landed. It had to land. And hence that was a failed mission. You must have seen various videos or photos of the ex-ISRO chief K. Sivan crying and the Prime Minister consoling him. So that was partially successful because orbiter was successful, these two not successful. The orbiter is still in the orbit, okay? And the best part is that the orbiter of Chandrayaan 2 helped the lander of Chandrayaan 3. Now we'll see this abhi. Now Chandrayaan 3 had a propulsion module. No orbiter. Orbiter is already there, successfully placed. That is why no orbiter over here. We had a propulsion module which was carrying the lander, which had to do the soft landing, and the lander contained the rover. Because this was unsuccessful, so we brought it here. Now this lander, propulsion module dropped this lander. It was August 17 somewhere. This lander was moving towards the surface of the moon, and while moving towards the surface of the moon, it established connection with the orbiter of Chandrayaan 2. The orbiter of Chandrayaan 2 was giving it constant information about the surface of the moon, the place where it has to land. Another difference between Chandrayaan 2 and Chandrayaan 3 which you need to know is that Chandrayaan 2 was a success-based design and Chandrayaan 3 was a failure-based design. Failure-based design simply means that the team of ISRO considered all aspects of failures. How can this fail? And they rectified, or they tried to rectify all those possible scenarios. They made the legs of the lander more sturdier, more strong. Here the landing area was limited to 500 meters into 500 meters area. Here it was expanded 4.2 kilometers into 2 kilometers. You can land anywhere. Then the landing site, or I would say the information which was getting received by the lander was much more enhanced as compared to the information being received by the lander of Chandrayaan 2. That probably has made us successful. And this is a classic example of learning from your mistakes and never stop learning. Now, we as aspirants should take this learning also, this I would say attitudinal learning or behavioral learning from ISRO. Despite the failure, you start working then and there. 2019 it failed. ISRO started working in 2019 only for the next mission. And now they're successful 4 years down the line. And this is, I would say, a mool mantra for success. So, all these things also should be learned. Next is implementation of the mission. Propulsion module will carry the lander rover configuration to a 100-kilometer lunar orbit. We know that. Once the Vikram lander module makes it safely to the moon, it will deploy Pragyan. We also know that. A successful soft landing has made India the 4th country after USA, Russia and China. You know, in 2019, when we failed to do soft landing, the very same year, Israel also failed to do a soft landing. Then 3 years down the line, that is 2022, last year, UAE and Japan, both of them failed to do soft landing. 2023, Russia failed to do soft landing. And you know what? Russia was the first country to do or to attempt soft landing on moon successfully. 1966 it was, 1960s, late 1960s it was. The Lunar 9 mission. So, these are some, I would say, statistics about this. What will Pragyan do? Pragyan will carry out in situ chemical analysis of lunar surface during the course of its mobility. We'll see what kind of analysis Pragyan will do. But yes, before that, we should understand the mission objectives. What are the objectives of this mission? Actually, according to ISRO, there are 3 objectives. First is to demonstrate safe and soft landing on lunar surface. Second is to demonstrate rover roving on the moon. And third is to conduct in situ scientific experiments. In situ scientific experiments will be conducted by rover, and the lander will also be doing or collecting some data. The lander will be standing at one position, the rover will be moving around. The lander, while coming down, was collecting some data. The lander, once it has reached, it then also will click some pictures, collect data, click pictures of the rover as well. And then the rover will be, analyzing the, I would say, moon soil, which is called as regolith. So, these kind of scientific experiments will happen. Through this mission, India will not only access a wealth of knowledge about the lunar surface, but also its potential for human habitations in the future. Now, this is something which is talked about a lot. Is this the main objective of this mission? I would not say that this is the main objective of this mission. Because the ISRO chief, the present ISRO chief, Mr. S. Somnath has said that, human life is, not possible on the lunar south. If it has to be possible, it can only be possible near the equator. It is more likely to be possible near the equator because the lunar south has extreme temperatures. Extremely low temperatures, I would say. Temperatures up to minus 250 degrees Celsius reach during the night time. The average temperatures, according to the internet, on the lunar south is around minus 13 degrees Celsius. So it would be difficult to survive in such conditions. However, near the equator, according to the internet, temperatures can reach to as high as 250 degrees Celsius also. Again, this points towards a question that whether human life is possible there or not. And to answer all these questions, to address all these questions, these kind of missions will give the answers to these questions. So, but yes, this is not the main, I would say, goal of this potential for human habitations in the future. Yes, we'll be collecting some data, we'll be doing some scientific experiments, and a byproduct of these scientific experiments, the outcomes can, signify whether this is possible or not. Now, why lunar south was chosen, this also should be, very much clear in your, in I would say your head, because UPSC, you don't know, can ask these kind of questions in the mains examination also. Now, our main concern, or our main, I would say, go to or look after, I would say, finding on the moon is the lunar ice. This is something which we are seeking, and lunar ice, it is believed in maximum amount it is present on the North Pole or South Pole. So, what was the importance of ice? They provide records of lunar volcanoes, material of comets and asteroids, origin of the oceans. Ice could be a source of drinking water on moon. If this is there, then obviously life is possible. Could help cool equipments for moon exploration and lunar mining. Now, lunar mining, a lot of, I would say, minerals are found over there, like silica is the maximum, then alumina, then lime, then iron oxides, magnesia, then titanium. These are some of the minerals which are, there on the surface of the moon. We have, found it already. And, there may be a possibility that we are extracting these kind of minerals from the surface of the moon and bringing them back to the earth in some future explorations. Oh, it is there. Then ice could be a source for hydrogen, because ice obviously comprises of H2O. So we can separate hydrogen, we can take out oxygen from it also. Oxygen for breathing, hydrogen for fuel. Again, this points out towards the fact that life can be possible. Then support to future Mars missions. See, there is one accord called as the Artemis Accord, which India has recently joined when our Prime Minister visited USA in June. Artemis Accords is an initiative by the USA. What is Artemis Accords aiming at? Lunar exploration. Manned mission to lunar exploration are also aimed, and beyond lunar explorations also we are looking forward. But the first step in Artemis Accord is lunar exploration. So it is there. It is expected that by 2024-25, under the Artemis Accord, the first manned mission will be launched from Earth to the moon. So this can definitely be helpful in the future missions as well. Now we talk about the payloads. Payloads are kind of those sensors which are there on the lander, rover, as well as the propulsion module. So one by one we look on all these three components. What are the payloads there? The first is the propulsion module. On the propulsion module, there is this payload called as spectropolarimetry of habitable planet Earth, SHAPE. It will look for smaller planets that might be habitable in the reflected light in our near space. It will analyze the light from the Earth to study its spectral and polarimetric properties as well. So this would be the job of this SHAPE. So it is there, rotating in the orbit, and it is believed that it can rotate or it can encircle the moon for years. So what will it do? It will do this, but nothing with respect to the moon. So we should be very clear on this. Next is the lander payloads, the lander which is landing on the moon. The first payload here is RAMBA. RAMBA stands for Radio Anatomy of Moon Bound Hypersensitive Ionosphere and Atmosphere. The name seems to be complicated, but yes, we need to simplify it. What will RAMBA do? It will measure the density of charged particles near the lunar surface and how this changes over time. The second is CHAST, Chandra's Surface Thermophysical Experiment, to measure the thermal conductivity and temperature of the surface of the moon. So we'll get to know the exact temperatures of the surface of the moon as well by this. Then instrument for lunar seismic activity, ILSA, for measuring the seismicity around the landing site. Seismicity means, is it shaking the land or not? Like earthquakes comes, so that is a seismic activity. Volcanic activity is also a seismic activity. So all these will be measured by ILSA. Then last is Langmuir probe as a payload in lander. It is to estimate the plasma density and its variations in the moon's surface. Now, the last is rover payloads. What are the payloads on the rover? Because rover has to go on the surface of the moon, conduct various experiments for the next 14 days. Now, that will be important. There are two payloads on the rover. The first is alpha particle X-ray spectrometer. It will measure the chemical composition and infer mineralogical composition of the moon's surface. What kind of minerals are present, in what quantity they are present. All these will be done. And second is laser induced breakdown spectroscope, LIBS. Now what this LIBS will do, it will basically use laser beams to melt a piece of lunar surface. Lunar surface is called as regolith, the soil, lunar soil, and analyze the gases coming out when this burning happens through the laser beams. So that is the experiment. Two experiments, the rover Pragyan is going to do. First is this, by studying the gases which come out by burning regolith by using laser beams, and the next is APXS, alpha particle X-ray spectrometer, which will analyze various minerals present in the surface of the moon. Now, obviously, this would not be possible without the team. Here in this particular segment, we are going to discuss the major members of the team. But yes, we should not forget that there were hundreds and thousands of people involved. And obviously, 140 crore Indians who were praying for them. Now in this segment, we will pick up the major, I would say, members of the team who were responsible for this, I would say, successful project. But apart from it, I also want you to know that there was 54 female scientists involved in this project. So let us look at them one by one. S. Somnath, he is the chairman of ISRO, and he is basically known for planning other missions which are coming up, that is Gaganyaan and Sun mission, Aditya L1. We'll be discussing them as well briefly. Then he is basically heading the Vikram Sarabhai Space Center. He actually served as, not heading, but he's heading ISRO now. Vikram Sarabhai Space Center and Liquid Propulsion Systems Center. So these two centers are being headed by, or were headed by him, and he is responsible for the present launch. Then the next is P. Veera Muthuvel, Project Director, Chandrayaan 3. He's an IIT Madras alumni, PhD holder, 46 years of age. He took over the Chandrayaan 3 mission in 2019 itself. And he was also known to, communicate with NASA, because this Chandrayaan 3 was possible, or there was participation by NASA also in establishing communication processes with this mission. So there was this partnership with NASA also, although on a very, I would say, particular aspect, that is communication. And he was the one who was in touch with the NASA officials. Then next is S. Unnikrishnan Nair. He is director of Vikram Sarabhai Space Center. He is responsible for making GSLV Mark III, or I would say Launch Vehicle Mark III, it is called as LVM3, which took this Chandrayaan 3. Then he has also become a popular face, S. Mohana Kumar. He was the mission director, and he is also responsible for launch of OneWeb India 2 satellites, LVM3 M3 mission that was, and LVM3 M4 mission is Chandrayaan. So he was responsible for the successful launch of LVM3 M3 and now LVM3 M4. He is a scientist, a senior scientist in Vikram Sarabhai Space Center. Then M. Sankaran, he is the director of U.R. Rao Satellite Center. Basically, Shankaran leads the team responsible for crafting satellites, designing and manufacturing satellites for ISRO. So many, I would say, equipments which are there used in as payloads, they have been designed by U.R. Rao Satellite Center, which is headed by M. Sankaran. And finally, A. Rajarajan, Launch Authorization Board Chief. Now this Launch Authorization Board is responsible for launching. You cannot launch without the approval of this board. So for successful launching of this mission, Launch Authorization Board was responsible, and the chief of our Launch Authorization Board is A. Rajarajan. Now what has India gained by this? Because see, in mains they can ask such kind of questions. And the first point which we are going to discuss here is prestige in the global scientific community. Now ISRO is known for launching, low cost space missions. People are comparing the cost incurred for this Chandrayaan mission is $75 million, which is actually less than the cost incurred for making a Hollywood movie, that was Interstellar. This movie got released a few years ago, and the budget for this movie was $165 million. That was just a movie, and this is a real life program. Now this has given confidence to many countries in the world which are low income countries, many developing and underdeveloped countries. Because everyone needs satellites and everyone wants to save money also. So they all can look up to ISRO. Okay, please launch satellites for us. And ISRO can take money from them for launching satellites, for giving these services to them. So this can be a major source of, I would say, forex for India in the time to come. India has leveraged immense soft power. Now the Prime Minister is there in South Africa for the BRICS summit. And from there, he was talking to the ISRO chief, and in today's newspaper, the front page, there is an excerpt from his speech. He said that this success is not only the success for India, it is the success of the entire humanity, the entire world, particularly the global south. If we, being a developing country, can do it, others also can do it. Whatever help you need, we are ready to provide you. And this is how he is leveraging soft power, or he is, taking advantage of our scientific developments. Obviously, countries all across the world need space exploration. And, ISRO can provide them this service. A good position in extraterrestrial minerals and resource research and exploration. Now, we stand in a very strong position here, because we can extract minerals, we can extract resources, we can have all the important data from extraterrestrial bodies. So this will definitely going to help us, and the success will inspire private space industries to push on innovation. Now last year only, 2022, India launched mission Prarambh. Prarambh was the first private space mission undertaken by a private firm called as Skyroot Aerospace. So India has allowed the private sector to participate in space. There's one body named as InSpace, which has been created under Department of Science and Technology, and the job of InSpace is to facilitate private investment in the space sector. Now this success of this mission will definitely give a boost to the private space industry, will motivate them to participate more, innovate more. So this is what India has gained from the success of this mission. Now what's next for ISRO? We should also understand this, because this obviously is not the end. This is one mission, one successful mission, which we were aspiring since 2019. Now ISRO has many missions lined up, but the prominent ones are Gaganyaan, which is expected to go in 2024. Actually, the launch date was 2022, but it has been delayed due to COVID. What it is a manned mission. Basically, 3 men and 1 robot. I would say humanoid. It is. Humanoid is kind of a robot only, but with the appearance of human. They are expected to go into the low Earth orbit and then return back. If this mission becomes successful, then we will open gateways for space tourism. So this is the Gaganyaan mission, which is planned in 2024. Aditya L1 mission is the next mission, aims to study activities of the sun. We are going to launch this, I would say, study mission in the Lagrange point 1, which is near to the sun and which will be studying about the solar activities or the activities on the surface of the sun. And these two projects are also, I would say, very close to the ISRO chief S. Somnath presently. So hopefully these two will be success. In fact, all of these should be a success. Then next is LUPEX moon mission. LUPEX moon mission is a joint or a collaborative mission between ISRO and JAXA. JAXA is the Japanese Space Agency. What it will do? Moon surface probe mission it is, just like Chandrayaan it is. We'll be probing the surface of the moon by this LUPEX mission. And Chandrayaan 4, 5, 6 to continue. Logically speaking, what should be the next Chandrayaan mission, or what should be the objective of the next Chandrayaan mission? It should be a sample return mission. Sample return missions are those missions which go from the earth, land on the terrestrial body, like here in this case moon, collect samples and return back to the earth. India has never done that, but Chandrayaan 4 logically should be doing that, although official details are not released by ISRO. But logically this should be the next step. Has sample return missions have they been undertaken by any other country? Yes. The first country to have or undertake this sample return mission was none other than USA in Apollo 11, 1969. Then followed by Russia. At that time it was USSR. Lunar 24, 1976. And very lately, 2020, China did it in Chang'e's 5 mission. Here also, if we are successful, and before us no one attempts this successfully, we will be the 4th country after these 3 countries. We have become the 4th country to successfully do soft landing after these 3 countries. The first country to do soft landing successfully was USSR, Russia. The first country to do a successful sample return mission was USA, followed by Russia, USSR and China. So these are some of the facts which will be important from prelims point of view. Now, as a matter of fact, it is a very proud moment for us Indians. We should undertake a lot of learnings, particularly those, I would say, mental toughness, behavioral learnings from ISRO, particularly us aspirants. If you face failures, stand up, learn from your mistakes, reattempt. There's no time for cribbing about anything. If you need to achieve great things, you need to have such level of mental toughness like the scientists of ISRO have. As a responsible citizen, I would, like to congratulate Team ISRO and the entire nation for this phenomenal achievement. And hence, Muh Meetha Karo. This is from, none other than Amul. So, I decided to, bring it here as well. So, we should be, tasting sweets, celebrating this success of ISRO and hoping for many, many more successes to come. So that is it from today's session. I'll be meeting you with some very important editorials as well as news pieces tomorrow. Till then, bye-bye, keep studying, keep revising. Jai Hind.